under classical mechanics is special theory of relativity. So this is a very much important topic where every year we get questions from this topic. So you can easily gain either 3.5 marks or 5 marks easily. So here I'll be discussing only the important points and important formulas required to solve a problem. So before we start, do it now. Sometimes later becomes never. So you're going to do it now. Okay. So let's start our topic where special theory of relativity basically uh, revolves around the frame of reference. So there are two frame of reference. One is inertial and another is non-inertial. So inertial frame of references are those that are at rest or that move with a constant velocity with respect to each other. And non-inertial frames are those which are either rotating or accelerating. So in here, these two frames are inertial frames which move with a constant velocity with respect to each other. And now, if you say that you have a inertial frame of reference, then there is no single frame of reference occurring in an inertial frame. So, uh, so if you say that the frame of reference is inertial, then you'll have two frames. Similarly, for a non-inertial frame, a single non-inertial frame exists. So you can have only one frame where you can say that okay, this frame is rotating or accelerating. But for inertial frame, you will have two frames because they move with a velocity with respect to each other. So there should be two frames. So let us see the important formulas. The first one is Lorentz transformation. This is okay. When frame S prime is moving along axis with respect to S frame, then these are the following formulas. And similarly, if you have to find if S prime is moving along y axis, then your y prime will become y minus dt by root over 1 minus v square by c square. So these are the basic things that you have to remember. And if you say that if S is moving along the x-axis with respect to S prime frame, then your formula changes as x is equal to x prime plus vt. So you'll have to note all those. And then the next important formula is the differential form of the Lorentz transformation. So these formula are very much required when we have to find the time between the two frames or the distance between the two frames or such. So this is very important formula. So note this. And then these are some of the basic formula. One is for length contraction and the time dilation. So for length contraction, you'll have like L naught. L naught is the actual or proper length. So wherever you get like the actual length of the rod is or the proper length of the rod is, it represents L naught. So keep this in mind. And next important thing is the velocity transformation or the relative velocity. So if you have two or three frames, and they say that frame A, B, C, they all move with velocity with respect to A. Okay, that is frame B moves with velocity V with respect to frame A. Similarly, frame C moves with velocity C with respect to frame B. So, in such kind of questions, we use this velocity transformation or this relative velocity terms. So just remember all these. You have to note this down, and you have to keep a formula notebook where you can store all these formulas and look whenever you have time. So let us see our problem. Here, two events separated by a distance 9 into 10 power 9 meter are simultaneous in one inertial frame. So it says that there are two events occurring and both are occurring at the same time. And the distance between the two events is 9 into 10 power 9 meters. So it is. I assume that it's happening in S prime frame. And then the time interval between these two events in a frame moving at a constant speed 0.8 c is. Here c is the speed of the light. And yeah, they have been asking the time interval between these two events with respect to the frame which is moving with constant speed. So I have given this velocity over here, but it goes to S frame, which is moving with respect to this other frame where the events is occurring. So event is occurring simultaneously, right? So there is no time difference for this frame. Hence the time difference here will be 0. And if you have to find the time interval between the events occurring in in S frame, moving at a constant speed, which is 0.8 c, then you'll have to find del t. And we have difference in the space to be, there is difference in the distance to be 9 into 10 power 9. So we have del x prime, and our del t prime will be 0 because there is no time difference, because both the events are occurring at the same time. And del t will be, we have to find del t. And we have v, which is 0.8 c. So on substituting on this formula, so we get the following, and I get to know that the time interval in this frame is 40 seconds. So I hope you understand this. So this is okay. I give you an homework problem which is similar to this problem. So you're going to use the same formula. This is a hint. So here the homework of, okay, I will discuss you the homework problem, but here I have given you the distance, and I have given you the time difference also, and I have asked you to find velocity v. So you have to fit it in the problem and then find the velocity. So let us see the solution for my previous problem, which was from central force problem. I had told you to find the angular frequency. So this was the question where we have the potential. So we know the first step is to use the effective potential, which is given as L square by 2m r squared plus V of r, and my V of r is k by r. So the condition for circular orbit is dou V effective by dou r, which is equal to 0. On doing that, I get my r to be L square by mk. So now I have to find my angular frequency. So how can I find that? I know that omega is equal to root over k by m. Or I can also use omega is equal to root over dou square V by dou r square by m. So I'm going to find my dou square V effective by dou r square at this equilibrium point. So I'm going to do that, differentiate again and substitute my r value. And after substituting, I get my dou square V effective by dou r square value to be m cube k power 4 by L power 6. So on substituting, okay, on finding the angular frequency omega, I get my omega to be mk square by L cube, which is option B. So I hope you all got this answer. So keep watching my videos, and this is my last session for classical mechanics. I'll be soon uploading a quick revision for classical mechanics. So stay tuned and watch the revision so that you get to know everything in a single video. So see you tomorrow. Thank you. Do not forget to like my videos, share my videos, and subscribe my channel. And also do not forget to hit the bell. So see you tomorrow. Ta-da!